Hey Logan, so your question was to do with exercise, not exercise, but question 4c. So let's have a look. This is for question 4 and 4c. So what did I do? They want you to find the intercepts. So that means you only need 2 points in order to sketch this graph, right? So the 2 points that we know is y-intercept and x-intercept. So we want to find the easiest one first. We're going to go with y-intercept. Y-intercept is the easiest one, if you didn't know. So the y-intercept, okay, so in your notes, have a look at your notes again. Y-intercept is when you don't know what the y-coordinate is, but you know that the x-coordinate is 0, correct? So I'm just going to write here, this is your x-coordinate, okay? So the x has to be 0. X is going to be 0. So in our equation, what do we have? We have y is equal to x divided by 4 plus 3. Yeah? So x, I'm going to replace that with a 0. So now I'm going to have 0. I probably should make it a bit thinner just so it works nicely. 0 divided by 4 plus the 3. That's what I'm working with right now. True? So finding the y-intercept, here we go. Y will equal to 0 divided by 4. You can use a calculator if you want, or we know that 0 divided by 4 is 0. 0 add 3, that gives us 3. So that tells me that the y value, so this y value is equal to 3, which means we now know that when x is 0, okay, then the y value has to be 3. So that's why my coordinate has to then be when x is 0, y is 3. Okay, so that's my first point. Now, the hard point to work with is to find the x-intercept. So let's do it over here. I'm going to do it over here. Same thing, go through your notes. So x-intercept, right? X-intercept is when we don't know what x is, but we do know that the y-coordinate is going to be 0. And this here is the y value, and the y value is going to be 0. So we go back to our equation and we say, all right, well, we've got y equals to x divided by 4 plus 3. And we know that the y value is going to be 0, right? So I'm going to put it here. I'm going to say, okay, y value is meant to be 0. And I don't know what x is. Divided by 4, add 3. Now we're going to balance the equation. Now, I can imagine some of the reasons why this question is hard for students is because of the fraction. Not because of the theory, but more so because the fraction is not the strong suit for a lot of students. In chapter 7, if you've done exercise 7, I'll just quickly show you where you can practice as well. In chapter 7, you actually work with fractions in exercise 7c. See how it says equations with fractions? So we've done all of that over here, and I've made some videos over here for you to watch again if you want to. But it teaches you how to get rid of those fractions and solve. Okay, so if you can solve these type of equations, then when you come back to this worksheet, this is a much easier problem. Okay, but here we go. I'll show you how we do it. So same thing, Sam Dobb, remember solving these equations, chapter 7. Sam Dobb, my hint to you, or at least the tip that I give to the class, is that I want you guys to get rid of the subtraction addition signs first. So anything to do with subtraction or addition, get rid of that first. So right now, if you have a look here, you can see this is a plus 3, isn't it? That's an addition. Whilst over here, this is x divide 4, isn't it? X over 4 means divide 4. So they're two different processes. One is a division and one is an addition. So my tip for you guys is to always get rid of addition and subtraction first. So right now, if you've got a plus 3, then what we're going to do is we're going to do the opposite of plus 3, which is minus 3. So I'm going to minus 3 on both sides to keep the equation balanced. And here we know that 3, positive 3, minus 3 is really like saying 3 take away 3, right? Which is 0. So this cancels out to be 0. And what I have left now is on the left-hand side, 0 minus 3 is negative 3. Whoops, I've already taken that off. Is negative 3. And then since this is 0, all I have left on the right-hand side is x divide 4. Now, this is key here. See, a lot of students hate fractions, but really, you're just doing the opposites, isn't it? Remember, this just means divide. This means divide 4. So if that's divide 4, what's the opposite of divide 4? See what I mean? Like if this is division, then what's the opposite of division? It's times. So instead of dividing 4, I can get rid of it by timesing 4 or multiplying 4 on both sides. See what I'm doing? And that's what chapter exercise 7c, if you go back to that, if you haven't done that or you've forgotten it, worthwhile going back to practice this because that's what chapter 7 is. That's what I'm saying. All of these skills here are very important. You have to really practice it. Otherwise, next year, that's exactly what you're going to be dealing with. You're going to be dealing with more fractions than what you see here. Okay, so what is the point of timesing it by 4? Well, over here we know that 4 times negative 3 is negative 12. Over here, on the other hand, what is x divide 4 and then times 4, right? And what most students don't realize is that this here is the same thing as writing 4 divide 4. That's what it is, because this is a 4, and then you're dividing the 4. That's like saying times 4 divide 4. Does that make sense? I'll write it again. When you write divide 4 there, you can also write it as x times 4 divide 4. It doesn't matter about the order. You can actually swap the order if you wanted to. So what this means is you're really saying x times the 4, and then you divide this by 4. See what I mean? But the beauty is that 4 divided by 4, we already know that's going to be 1. So x times 1 ends up just being x, which is why some teachers just say it just cancels out. But it doesn't. What it actually does is you're just doing 4 divided by 4, which is 1, because they're inverses of one another. Okay, and then you get x is equal to negative 12. And so that's why your coordinate is negative 12, 0. Okay, so that's your final part. So really, what was the hard part of all this? I wouldn't say that the hard part was the addition or subtraction. What was hard for a lot of students is this fractional step. Okay, so you're really used to doing something like this. If I gave you 4 and I said this was 2x and I said solve for x, most students memorize this. They just go, oh yeah, divide 2, divide 2. They're not really understanding that this is times, that's divide. Then why can't you do it the other way? Why can't you have x over 2 and then we just do the opposite of that, which is times 2? There's nothing wrong with that. If you can do opposite of times, which is divide, why can't you do opposite of division, which is times? It's okay. There's nothing wrong with that. And so it's the fractional part that students generally find tricky that I want to encourage students to continue doing fractions because it's not meant to be scary. It's the same process. I mean, I can even show you on a calculator. Yeah, I'll get out a calculator to show my point. Have a think about this. We said x divide 4 and then times 4, yeah? So a lot of students feel confused. They don't know what to do there. The reason why it's confusing is because there's the x, right? Well, what if I didn't give you x? What if I gave you 5? 5 divide 4 and then times 4. Let's see what happens if I put on my calculator. Here we go. 5 divide 4 and then times 4. Let's see what it equals to. Hey, equals 5. Can you see a pattern here? I'm going to show you a pattern. So this is 5. This is 5. Watch what happens if I change this to now 7. 7 divide 4 and then times 4. Let's see what this equals to. Okay, so let's see the pattern. I hope that you can see the pattern here. 7 divide 4 and then times 4. Look, it equals 7 again. So, are you starting to see a pattern here? I'm going to pick now a really random number. I'm going to do 101.72. And I'm going to say divide 4 and then times 4. What do you think the answer is going to be? Have a think. What's the pattern? So the pattern here, let's see. I'm going to do 101. So I'm going to make it up here. So 101, 101.72, divide the 4. And then I say times the 4. Look at that. It still equals 101.72. See what I mean? And the reason why, and so if I asked you, what is x divide 4 and then times 4? Well, hopefully you see the pattern is it's going to equal to x. And you're wondering why this happens, because remember, division, if you're going to divide a 4 and then you're going to times 4, you're just doing the opposite of what you're doing. It's like, I'm going to make it smaller and then I'm going to make it larger. I'm going to halve it and then I'm going to double it. Or another way a lot of students relate to, if I add 2 and then subtract 2, technically you've done nothing. That's essentially what you're doing when you're doing the opposites of each other. That's why it's so important to find out what the opposite is, because when you do the opposite, technically, you haven't changed anything. Or another way of thinking about it is, when you write it out, you're saying 5, okay, divide the 4 and then times the 4. Or another way of thinking about it is 5 times the 4 and then divide the 4. It doesn't matter about the order when it comes to times of division, but one of the beauties is we know in fractions 4 divided 4 is 1. And 5 times the 1, of course it's got to be itself. That's why all of this step here is really just saying times 1. All of this. That's a real deep understanding there. So if you understood what I just described there, fantastic. If you don't, if you're a bit confused, it's okay. You just got to learn the skill to do this. Okay, so hopefully you understand now how I got 0, 3 and negative 12, 0. So going back to sketching, we can now say negative 12, 0. So I'm just going to say it's over here somewhere. So negative 12, 0. Remember, you don't need to do that marking. Don't do that. It takes too long to do. And 0, 3, well, 12 is a really big number, isn't it? In the negative direction. So 3 should maybe be about a quarter of it. So maybe here. So I'll do it there. 0, 3. Use a ruler. Here we go. There's my ruler. That's my 2 points. And here we go. I'm going to sketch it. There we go. Put the 2 arrows at the end of each one and then write y equals to, what was the equation? X over 4 plus 3. And that is a perfect graph. See what I'm doing? So I'm going to zoom out and you can have a look at this section here. Have a think. This is obviously the part that you need to know. So I'm just going to box around it. This is what you need to know. Over here, on the other hand, is me trying to explain to you why it works. Okay, if you don't understand it, it's okay. It's just I'm trying to show you that don't be afraid of divisions. Don't be afraid of fractions. It's what most students tend to fear and avoid. Don't avoid them. Okay, but otherwise, if you want more practice on these types of fraction equations, really make sure to go back and check your 7C. Have you done these questions? And if you have, maybe you want to practice more. Okay, it's about training yourself that you feel more comfortable to do something like this, like that, like this, or like this. Technically, the one that we just did just now is more similar to none of these, really. Oh, more like, oh no, actually that's a bit harder. No, there's nothing that you can relate with besides these ones. These are actually even harder. So if you can do those, then you can do the one we just did. In fact, actually, this is more similar to what we just did. Yeah, that's more similar, except it's even harder. It's even harder because you got that 7 there. You can write it as m over 12 minus 12 equals negative 5. If you can solve this, then you're on the right track. That's what you're trying to do. So that's why I'm saying go back to exercise 7C, train your algebra so that you're ready. Okay, I hope this video helps. I'm going to go back here, pause the video so that you can copy the notes if you like. But that's what I want you to be able to do there. Okay, I'm going to zoom out right there. You can pause the video here.